Hello everyone. In today's video, I will be going through chords, tangents, secants, all that stuff that will help us finish off what's in this spinner. So make sure you have yours handy. All right, so let's do a little bit of vocab. We've already talked about chord a bit. A chord is a segment with endpoints on the circle. And there are a few examples of chords in this circle. One chord example is AD. So it's a segment and then the endpoints are on the circle itself. That's how you know. So we have AD and then we have BF and C. So those are all the chords in the circle. Tangent and secant, these are lines, and so that automatically kind of just differentiates them from a chord. And then on top of that, you've heard the word tangent before. This is different from the tangent trig function that we talked about for the last unit. So two different things. Tangent is a line that intersects, or if you prefer, crosses a circle one time. There is one example of a tangent in this circle, and it is this line here with the E on it. Also, we need to add a point to this line H because it's not proper to use one letter to name a line. We need two. So I'm adding an extra letter for that reason. So line EH is a tangent line. And lastly, we have secant. Secant is a line that intersects, or if you prefer, crosses a circle two times. So for example, there is one example in this circle. It is BF, but specifically line BF. So the difference between the BF and the secant example and BF and the chord example is which part of BF we're focusing on. For a chord, we would focus just on the endpoints. So that what is still exposed here that I'm not covering up, that's BF segment chord. With the arrows included, now this is BF, the secant line. So every secant line has a chord in it. That's what makes it secant. One more term here to mention, and that is at point E. This actually has its own name. It is called a point of tangency. This definition is pretty intuitive. It's just what it sounds like. It is where the tangent touches the circle. Alrighty, those are our definitions. So from here, I have 4 examples below, and I'm going to show you how if you're able to identify what type of lines you have in your circle, you can easily find the correct problem or picture, formula, what have you, to look at on the spinner to help you solve the problem. So let's start with number 1. Number 1, we have these two lines here. We have WY and we have WS. WY touches a circle one time at W, so this is a tangent, and W is the point of tangency, and the WS is a chord. It's a segment, it doesn't go beyond the circle, so it's just a chord. And now that I've revealed which ones we have, I'm going to specifically add in my symbols. So this is a tangent chord. So here's the nice thing about this circle. You could just look at all of these until you find the right one, or tangent chord is what I just identified that as, so let me find it. Right here, tangent chord, I'm going to go to this section of my circle, and let me compare this to the problem I have here. As you can see, those are very similar pictures, so I have found the correct one to use for my problem. And before I get any further, I do need to give you some kind of information so you're able to actually solve a problem here. Again, strongly recommend color coding for these problems, but it's completely up to the person. So, let's start with WS. WS is 118 degrees. And going off of that, I want you to find the value of SWY, that angle. I recommend each time you highlight a new part, use a different color just so that they all stand out against each other. So the goal is to find the measure of angle SWY. So if we use our formula, this says that the formula is that the angle is half of the intercepted arc. So we have our angle, that's what's in blue, and then the intercepted arc is the orange part because it does go inside the angle, in between the points where the angle touches the circle, that kind of thing. So the measure of angle SWY is 1/2. I'm taking this information straight from my spinner. Of our intercepted arc is SW. So it's 1/2 of, our arc is 118. So it is 59 degrees. And that's it. Number 2. Again, we start by asking ourselves what type of lines we have here. I have BR and BK. Right off the bat, they extend beyond the circle, so they are lines. So on that alone, they can't be chords. And then I know it can be hard to see, but BR goes through the circle at Z and R. You can see a little portion of the circle outside on the left side of the line. So that tells you that it definitely goes through the circle completely. So this is a secant. And the same thing happens with BK. There's a little bit more of the circle cut through, so it's a bit easier to see. This is also a secant. So this is a secant, secant. So again, we look on the circle until we find the name we're looking for. And here we go. It's abbreviated, but it's there. So this is one of 3 examples here. Secant, secant is the bottom one. If you want to add this to your circle real quick, we have 3 of these examples, and they are in order in the way they're listed here. So this top one is tangent, tangent. The second one is tangent, secant. The bottom one is secant, secant. They're all solved with the same formula. It's what I have written up here. Technically, what we're doing here is we are taking half of, and then in parentheses, we are doing the big arc minus the small arc. I just ran out of room to write this stuff. So 1/2 big minus small is how we're handling these problems here. So that's what we're going to do in order to find our angle. And again, I need to give you some information. So ZF is 58 degrees. And RK is 168 degrees. So we're looking for angle B. So let's use our formula that we just discussed. It is 1/2 of big arc minus small arc 1/2. Our big arc is 168. Minus our small arc is 58. So that is going to be 1/2. 168 minus 58 is 110, which is 55 degrees. So angle B is 55 degrees. All right, 2 more. Number 3, again, we need to identify what we have here. We have VW and FL. These are both chords. They don't go outside the circle, they are segments, and the endpoints are on the circle itself. So these are both chords, they're both segments. So chord, chord. Again, go to the circle. This formula is very similar to the one we just used. It's kind of the opposite, actually. Instead of subtracting these two and taking half, we're adding them and taking half. So let me give you some information first. Let's say that arc VL is 95 degrees. And then since I know this is how I'm going to solve this problem, I'm going to go ahead and highlight it all the same. And this arc is 143 degrees. And let's say we're trying to find this angle here. So that'd be angle LBV. So again, going back to our circle with that, we've got these types of arcs here. And the thing to notice is that we have vertical angles in the middle. So you want to make sure that with whichever pair of angles you have, you do have the arcs that work with them. So if this is our pair of vertical angles, we do have the correct pair of arcs to use. So you just plug them in. 1/2 of arc plus arc. So measure of angle, LBV, is equal to 1/2 of our two arcs, 95 plus 143. 1/2, 95 plus 143 is 238. And half of 238 is 119. So LBV is 119 degrees. Just a little side note, since these are vertical angles here, if this question mark that we just found is in 119, so is this one. Again, since they're vertical. All right, one more problem, number 4. And I want to add a point here for just a moment. And then let's identify what type of lines we have here. We have JP and DL. JP is a tangent. Touches the circle one time. That point of tangency is D. And then DL goes straight through the circle. It has arrows on it. So it crosses twice, making it a secant. And since it continues in both directions, it's a secant and not a chord. So these are both lines as well. So here we have a tangent secant. Let's look in our circle. Now, there are 2 spots that say tangent secant. However, the pictures are very different, so you'll be able to tell which one's yours. So if we look at our example compared to the tangent secant in the spinner, there's no way these are the same problem, not even close. The main difference is on the spinner, this vertex, this angle is outside the circle, whereas in our problem, the vertex is on the circle. So let's try the other one. And if we look, we basically have the same type of picture going on here. So we're going to use that one, and this is actually the second time we're using it. This time, let's say that our arc DVL is 200 degrees. And we need to find the measure of angle LDJ. So here's the thing with this problem. If we look at our spinner example for just a moment, there are 2 examples in here. I've got the orange one and the green one. So for the orange one, we have our angle and our intercepted arc. The angle is half of the arc. Arc is 100, angle is 50. And then same idea with the green one. Our angle is 130, our arc is 260, and 130 is half of that. So we have the pairs, arc and angle together. When we look at this example, and especially when we compare it to number 1, notice how in number 1, we had the angle with the arc, correct arc highlighted. In our example, we have the angle and then the wrong arc highlighted. We need this arc over here. So if you try to put this 200 straight into the formula, what you get out of it is not going to be the correct answer. It's not what we're looking for. So let's start by finding our correct arc. Remember, this is a circle. It's split into two pieces, the orange piece and then the blank piece that I need to find. And we remember the whole circle is 360 degrees. So this part's 200. What does this have to be to make 360? This blue section needs to be 160. 160 plus 200 gives us 360. Now that I have the correct arc that I need to find this angle, now I can go straight into the formula. So reminder, the formula for this problem is that the angle is half of the intercepted arc. So our angle is LDJ, and it's 1/2 of our intercepted arc, which we now know is 160 degrees. And 1/2 of 160 degrees is 80 degrees. So LDJ is 80 degrees. And that's it. All right, that is all for this video. I went over the gist of the different types of formulas with practice and with seeing different problems. These are going to feel a lot easier, but I highly recommend the strategy of identifying what type of segments you have before going through the problem. It will make your process a bit easier and you'll feel a bit more confident in what you're doing. If you have any additional questions for me, feel free to come see me in person or to send me an email. Otherwise, you have a wonderful day. Bye.